Hi, welcome to my next tutorials using the L'Hopital's rule to solve indeterminate limits. What are indeterminate limits? Suppose we have a limit as s approaches 0, s minus 1 over x. Then we can say limit as s approaches 0, s minus 1 over x is indeterminate if we are going to end up dividing 1 by 0, which is not accepted. Let's talk something more about infinity. Infinity is one non-higher number that you can think of. We don't cancel infinity as in 1. Never do we multiply infinity by infinity to get infinity square. Also, we don't add or subtract infinity. This is because the biggest number you may think of may be lesser or higher than what I may think of. Suppose we have a limit of indeterminate form. The L'Hopital rule states that limit as s goes to 0, f of x over g of s is equal to the derivative of the top function over the derivative of the denominator or the down function. Example, limit as s goes to 0, s minus 1 all over x is an indeterminate limit. So here we can use the L'Hopital rule by finding the derivative of the top function and then finding the derivative of the down function. You can go through this example by putting in 1 at wherever you find x and see whether you are going to get an indeterminate answer, and then if yes, then try to use the L'Hopital rule to solve it out. Do you remember this in my previous video on using the first principle rule to find the derivative of sine x? The limit as h goes to 0 cos h minus 1 over h is 0. The limit as h goes to 0 with sine h over h is also 1. Here you can use L'Hopital's rule to prove whether limit as h goes to 0 cos h minus 1 all over h is 0, and the limit as h goes to 0 sine h over h is also 1, since these are indeterminate limit. So here we just differentiate the top function and we differentiate the down function. So differentiate cos h minus 1 all over the derivative of h as the limit h goes to 0, and we know that when you differentiate cos h you get negative sine h as usual. So you are going to end up getting negative sine 0, and sine 0 is 0. And then the second one too, sine h over h, you differentiate the sine h and you differentiate h. Know that in my previous video I taught you when you differentiate sine h, the answer is cos h. So cos 0 is also 1. Click the share button, subscribe.